Hello friends, in my this video I am going to discuss another very interesting linked list related problem, and the problem title is intersection of two linked list. So from the title itself we can clearly understand what we have to do. Basically we will be given two head node of two different linked list. We have to find out what are the intersection of the data elements of the two linked list. That intersection or the common element we have to store in another linked list, and that linked list head we have to return. That's what here it is written. Given two linked lists, the task is to complete the function find intersection that returns the intersection of two linked lists. Each of the two linked lists contains distinct node values. This is very important, distinct node values. Okay, because we are going to find intersection, and you know that in intersection obviously the elements, each of the two linked list contains a distinct node values, means that is basically set, right? In set we apply the intersection concept, and you know that in case of set you cannot store any repeated elements, okay, or duplicate elements, so that distinct nodes are present. So try to think about one algorithm which can be used to solve this particular problem. Okay, implement that in NetBeans or Eclipse or in some other online compiler. Simulate and run it and check whether that is giving correct output or not. If it is giving correct output, well and good, but if it is not giving correct output, no need to worry. Here I am explaining. So see here, let me directly go to the input test case. Suppose my first one is, so basically this first input is indicating number of test cases. Here one means only one test case. Okay, like generally you know you are habituated, right, with this basic input format of gigs for gigs. Anyway, now this 6 indicates the length of the first linked list. So see here, you can see there are 6 nodes, and the data elements are 9, 6, 4, 2, 3, 8. And second one has 4 nodes. The second linked list data elements are 1, 2, 8, 6. So if you perform intersection, the common elements you will get as 2, 6, 8. Okay, that's what you have to put in one linked list, and you have to give that as out. So what algorithm I am going to follow is very simple. What I will do, first I will store all the data elements of that first linked list in the set, in a set. Okay, whether that may be tree set, linked hash set does not matter for the fact. So what we will do, so first the first linked list elements we will store in a set, and for the second linked list we will traverse from the beginning to the end, and we will check whether that particular data element is present in that set or not. If that is present in that set, that means that data element basically common in between these two linked lists. Then in that case we are going to store in a separate array list, and then after execution, after traversing from the beginning to the end, what will happen in that array list, the common elements or the intersection elements will be stored, which is common in between these two linked lists, and using that array list we will create another linked list. Simple idea, right? So here is the code I have written. So see, node class no need to write because it is already written, class node, and you know that each node has two elements, one is data and another one is reference to the next node. So int data is of integer type, and node next. Okay, and here is the constructor of the node class, node in data, this dot data equal to data, this dot next equal to null. Okay, in programming if you want, if you have to write the whole code, then you can ignore this line also, because by default next will be initialized as null. Okay, now this is our original code. So class gfg is our class name. Static node find intersection, node head 1, node head 2. Okay, find intersection is our function name. Node is our return type. We have to return the linked list node which will contain the intersection elements, and node head 1, node head 2, that means two head pointers of the two linked list we are passing through our this function find intersection. We are creating here the array list which will store the intersection elements. So array list integer a equal to new array list integer. Why integer? Because here from the node class itself we can get an idea that linked list only contain integer data type, because here you can see in data. All right, now I am creating one set, that is basically tree set I am using here. You can use hash set or linked hash set, does not matter. Let me write here hash set, because in hash set searching algorithm is much faster. So set integer b equal to new hash set integer. Okay, then while head 1 not equal to null, b dot add head 1 dot data and head 1 equal to head 1 dot next. what I am doing here, basically I am traversing in the first linked list which has the head pointer as head 1. Okay, I am taking the value part, that is using this command head1 dot data, and I am storing in that set which I have created here, set b. Okay, and then I am going to the next node, head1 equal to head1 dot next. Similarly, I have to traverse now for the head 2, and I have to check whether a particular element of head 2 is present in the set B or not. If it is present, that means that element is common in between two lists. Then we are going to store that in the array list which we created here. That's what I have done here. While head 2 not equal to null, if b dot contains head 2 dot data, that means if the particular data element of a particular node of linked list whose head is head 2, that is second linked list, if it is already present in this set, that means it is common element. So we are going to store in the array list a dot add head 2 dot data, and then we are going to next node. So head 2 equal to head 2 dot next. Then this head 1 I am making as null. Okay, so that means I am completely destroying my first linked list to create one linked list which will contain all the data elements which are basically common in between linked list 1 and linked list 2, which we have passed through our this particular function. Okay, all right. Now I always suggest that when you are making a new linked list, always add a node in the beginning of the linked list, because to add a node in the beginning of the linked list you don't require any loop. But if you want to add data element at the end of the linked list, then you have to use one while loop for traversing to the end, and then only you can add there. So that is one problem. So to avoid that, I always prefer to add data element in the beginning. So if you want to add data element in the beginning, so what you have to do, you have to reverse the original elements, right? So that and one more thing, let me mention, otherwise you will get confused. Here it is clearly written that uh, one second, the function should return reference point of the head and the new list formed by intersection of two lists. The new list, see, the new list formed should be in non-decreasing order. That means it is should be ascending order, right? So for that I have first sorted my array list collections dot sort a. So as a result, what will happen, the intersection elements will also be sorted, and as I want to add node in the beginning of the linked list, so that I am reversing my array list first, and then I will follow the beginning addition of node rule. Okay, so collections dot reverse a, and then in temp equal to 0, while temp less than a dot size. So I will use this, I will create each and every time one new node until this condition is satisfied. Okay, node Ramu equal to new node a dot get temp plus plus. So I am creating one node object of name Ramu. Okay, and I am passing this value a dot get temp plus plus. So as a result, this will call the constructor of node class, and it will create the node, and the node in the value part the data will be put, and this dot next equal to null one reference will also be created. Now for the reference part, reference, that is Ramu dot next equal to head 1 equal to Ramu. This is nothing but how we add node in the beginning. If you don't know, please check that first, because this is very important concept. I will post that link in the description also. If you want, you can check there. In the Geeks for Geeks itself, the documentation is clearly written what is the algorithm, how you can do that. Anyway, and then finally return head 1. Okay, so let me submit that and show you whether my code is working or not. So this type of programs are very important for different service and product company based placement process. Here you can see different company tags are there, and very high level big four companies also, like big companies, big product based companies also ask this question, like Amazon, Microsoft, etc. Okay, Walmart also, Flipkart also. Okay, so practice this kind of questions. This is surely going to be helpful in solving higher order thinking problems which appears most of the time in different service and product company based placement process. See here, execution time 0.27, correct answer. Okay, so I hope you have understood the algorithm. This is all for my this video. I am going to post the same code in the comment section of my this video. If you want, you can check there. Thank you for watching.